Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Klamert, your host, and today on episode 45, we're going to continue our discussion of mDNS best practices. And with that, I'd like to welcome back to the show Al Dumdei. How are you doing today, Al?
Hey, Dan, doing great. Doing great
Thanks
here
for.
in not sunny Vancouver today.
All right. Uh-oh.
Imagine that.
Raining, yeah, raining or cloudiness in the Pacific Northwest. Yeah.
Yeah.
Who'd have thought?
But it's a beautiful city for sure.
Yes, that's for sure. That's for sure. Well, thanks again for taking the time to join us here today. So before we get going and get into the topic, we do have Slido up and running as usual today. So if you can join it using the QR codes on the screen. If you're joining us via YouTube, you have the link there under the video on our YouTube channel at youtube.com/@getunplugged. You can go there and submit your questions, and we will either answer them live on the air today as we broadcast, or we do have some people that are standing by to answer those questions too, depending on the flow. But we definitely have time today based on our agenda to answer your questions. So get those in and submit those as we go through. But if you, as a reminder, we do record this. This is on our YouTube channel, which I just mentioned. Please be sure to go out there, like and subscribe. And when you do subscribe, it helps the channel reach others. And then also it helps you by notifying you when we do go live with other great content like this. So now let's get into it. Let's get unplugged. Al, I know we covered mDNS a little bit on, I think, episode 42. So should we start with a quick
Yeah.
recap? Bring everyone
Yeah.
up to speed?
Let's do that. Let's do that. And I think that'll kind of help us sort of explain the difference in what session 2 here is about versus what session 1 is about too. So I think that's a good idea. Let's start with kind of what we've talked about in the past. So if you look at this particular example, if you see this is the traditional version, if you will, of what we do with mDNS on wired. So on wireless, sorry. So if you look at the configuration, we have switch 1. Switch 1 has a couple of things plugged into it. You'll notice that switch 1 is trunked to the wireless LAN controller, right? And then switch 2 just has a traditional, what we call a centrally switched access point. So I'll try to use the centrally switched or locally switched terms rather than local and flex connect or that sort of stuff. So, so this is a centrally switched access point. So what'll happen is, let me back up here. So what'll happen is anything that enters that AP will get basically tunneled up to the controller. And then we have this other switch layer 3, which is layer 3 from the controller. So there's no direct layer 2 connection, no trunk between that switch and the controller. And so we have different clients, D1, D2, D3, D4, and D5. D1 is, and then what we've got the wireless LAN controller set up as a gateway. And if you'll remember on the last time when we did this, we went through how to configure the wireless LAN controller as a gateway and all the different parts around location-based services and filtering and all that sort of stuff, right? So, and the wireless LAN controller does a great job of that. In this particular case, when we trunked the switch up to the wireless LAN controller, the switch learns all of the mDNS traffic from the trunk link, right? From that VLAN that's trunked directly to the controller. So VLAN 30, it picks up the wired D1. D2 in this example is toast, basically, right? Because there's no direct connection to the wireless LAN controller. But we're going to fix that in this second episode here. And then in this particular case, like we talked about with switch 2 and the AP that is set for centrally switched, in that particular case, everything's trunked up. So we basically have a CapWeb tunnel or a multicast CapWeb tunnel that pulls that information up to the controller, which goes up to the gateway, which allows us then to manage anything going from, say, D4 to D3 or D4 to D2. All that can then be managed by the wireless LAN controller. Now we have D5, and it's sitting out there on switch 3, which is connected through some layer 3 links, could be multiple hops. What do we do about that? So in this particular case, we've got something called an mDNS AP, which is basically just an AP that's running a trunk off the AP and sniffing the VLANs. And by it sniffing the VLANs, we can pick up the Bonjour services available from D5. And of course, we can also advertise to D5. And remember, Bonjour, if you remember, it's really, we kind of covered this last time, but it's DNS, right? But it's using multicast for DNS, to do DNS. But it's a unique sort of multicast because it's link local, right? So there's we typically think of, hey, it's multicast, so let's do, PIM and let's route this multicast. No, because it's time to live in one. It's link local, so you can't route mDNS traffic. So that's why we use gateway. So if we want, for example, D1 to be able to communicate with D5, in this particular case, because we're using the wireless LAN controller, it can do that using the gateway on the controller. Now,
and then,
if
Al,
you notice,
can you refresh our memory on that mDNS AP role? Can that AP be doing other things as well, or?
Absolutely. Absolutely. That's a great point. So that AP that's running mDNS, that's like a sub-mode of what that AP is doing. So it's snooping traffic, but it's also performing your typical AP duties, right? So it's still client serving at that point. So it doesn't have to, and that's a great point because we have had APs in the past that are used for sniffing for whips and stuff like that, intrusion detection, where we might put it in a closet. That's not the case for the mDNS AP. This could be it's a serving AP that we've dubbed basically as this mDNS AP and run and trunk VLANs to it. So,
great, thanks.
No, good question. Yeah. So now if we look at this, if you notice, there's two little dots. There's a BA on the wireless LAN controller, and there's a little BA, and I've dubbed that as a Bonjour agent. And we'll talk more about what that means. And actually, agents are a bit of a generic term, and we're going to use them in a specific way in a little bit. But one of the other ways I could do to solve this same architecture is by using a Bonjour agent on a switch, and then I can tie layer 3 domains together using a controller. All right. So what does that look like? So if you're familiar with this in the past, you probably have heard of this as the wide area Bonjour gateway or the wide area mDNS solution. There's really 3 layers to this. The first layer is the service peer. And the service, and by the way, you can take any one of these layers by themselves. You don't have to have all 3 layers, but you can have up to 3 layers of this. So the service peer is basically a layer 2 switch. And I can define things like, and we'll look at the configuration and that sort of stuff, but what gets advertised, what gets received as advertisement. So those particular filters around the mDNS traffic, I can put on that service peer. I can also put those on an agent. The agent, however, is typically what you'd think of as like a distribution switch in your architecture. And the agent then would communicate directly to the controller. And that's really the function of an agent. The function of the agent is to be able to communicate up to the controller. The purpose of the controller is to bridge these different locations together, right? So if I have a switch and I have 2 different VLANs on the switch, or I have this service peer and a service agent, maybe I have 2 or 3 service peers attached to a service agent, I can bridge those VLANs. First of all, let's say all I have is a service peer. I can bridge VLANs in a service peer by itself. I can define a switch as a service peer and bridge VLANs using a gateway on the switch. If I want to do this across multiple switches in like a facility, for example, let's say this agent is in my mDNS, and I want to tie all my IDF closets together, and I've defined the IDF closets as a service peer, I can do that, right? And I don't need to have the wide area Bonjour agent, the controller yet, because at this point, I've either just had a switch and VLANs inside the switch, or I've tied that switch to the distribution layer, and now I've got maybe a building of switches that I'm able to run this gateway functionality. And we're going to talk about what we can do from a location-specific characteristic here. One of the things, if you think about that previous architecture we discussed, if I want to really be able to control where my wired traffic goes, I'm either going to have to put out multiple mDNS APs, or I'm going to have to do a lot of filtering and that sort of stuff on the wireless LAN controller. You have to go back and look at episode 42 for the configuration of the wired side of that. But this really lends itself well towards being able to manage it down to the switch port level, right? So we can manage both wired and wireless together. Now, so now let's say I want to cross from building to building. That's where the wide area Bonjour gateway comes into play. And with that wide area Bonjour gateway, we can define different locations in the gateway. And then we can define what services we'll allow to be advertised from agent 1 to agent 2 as an example, right? So we have another degree of filtering that we can use. And if we had agent 3 and agent 4, we could determine, does agent 1 talk to agent 2? What can it pass? What kind of mDNS traffic can it pass? Can 1 talk to 3, and what can it pass? So all of that hierarchy can be defined very, very precisely, right? The other thing that I really like about this architecture is, as opposed to the previous architecture, architecture relies on something called flood and learn. So if you remember that first AP, or that first client rather, that it plugged directly into the switch, the way the wireless LAN controller learns about it is we're flooding that VLAN. With this, we're stopping that flooding, right? So this is much better from a switching environment. You're going to have a lot less traffic. And again, I can control wired and wireless on this. So if you look on the right-hand side, you'll notice that the service peer is actually a wireless LAN controller. All right, so let that sink in for a second, right? We've been talking about switching for a little bit. So I can define a wireless LAN controller, and I can define locations based on APs, just like I do based on port groups. All right, we're going to look at that in just a second. But in general, what that allows me to do is I can group APs and port groups together. So I can say, hey, if my board, let's say it's a WebEx board and it's broadcasting, it's got some mDNS functionality, and I want to only allow that to be broadcast on this particular AP, I can form a group with that switch port and that AP and contain that traffic to just those 2 locations, right? So there's some really great granular control amongst wired and wireless by doing that. So in this particular case, we're not using the traditional methods that we typically use on the service peer or on the wireless LAN controller. We've made it into a service peer rather, and now it's part of this overall wide area bonjour capability. All right.
So Al,
yeah.
for these capabilities you're talking about here, we have a question around, are there specific versions of software that you're talking about here, or that it's around code versions, the question?
So I believe the Bonjour Gateway's been in at least since 17.3, but it definitely got some updates in 17.6. So probably, and a few more actually in 17.9. So I would say, like location, if you're doing location-specific services like that, you probably want to be on 17.9 or up on your switching to really get the full benefit of it. But it's been, if you're just running basically Bonjour services on a switch, that's been around at least since 17.3, maybe before. So yeah, you could just run that on a switch itself. One of the other architectures I think that's kind of interesting is, let's say that you didn't want to do a service peer. Let's say you've got, I don't know, you've got a third-party switch down there in this particular architecture where we have a service peer. You could trunk that up to the agent, and then still based on the ports on the agent, determine ports and VLANs on the agent, determine what you would advertise down to that switch. Now, you can't stop the flooding at that point. That's, you're going to get flooding from that layer 2 switch, that we'll say third-party layer switch, up to that agent. But you could do that, right? And so, and maybe this is even a way, depending on what you want to do from a licensing standpoint, to run the Bonjour Gateway agent, you need a DNA Advantage. But let's say you didn't want to put Advantage in all your layer 2 switches. Maybe some of them you could just run Essentials and then just run it as a layer 2 and then do it on a port. So it gives you that flexibility. You can get the right licensing, the right flexibility for the right applications, right? So it's really kind of a cool architecture. So we talked about this, but I'm going to dive a little bit deeper into this. So I think there's really, if we think about, let's say you're running Flex Connect or you're running Meraki, right? And maybe you don't have a way to do, or you don't like the way that you do location services on that particular locally switched access point. All right. So so now I can add some location-based services on top of my Bonjour filtering. So I now have two locations I can do Bonjour filtering. I can do it on the access point, but I don't. But I may not have the location services on that. So I could do the location services and maybe to some degree the filtering of the particular types of mDNS traffic on the switch, and then further filtering on the access point itself, right? So as an example, let's say we want to do a per building. Let's say that if I walk into this building, I don't care where I'm at in the building. If it's a wired or a wireless mDNS, it's an Apple TV in the building someplace, I want to be able to see that. In that particular case, we're going to run the per building. So the per building architecture is basically what you saw. Well, we'll just go back here to this, where you have this agent over here, right? And service peers. So all my IDF closets would be service peers. My MDNF or my MDNS or my MDF, sorry, or my distribution layer switch would be that agent, and it would then effectively route between the different VLANs across and the different switches across my architecture. So now I could have an access point anywhere in that building, or I could have a wired switch port anywhere in that building with mDNS services on it, and that would get advertised to anything else on in the building, wired or wireless. Now I can do this on a what we say per floor basis, or we'll say per IDF basis. So I could take a switch or switch stack, and I could take that and define that locally and say, okay, I only want to share that amongst that switch stack, right? So only if you're in, let's say I have an IDF per floor. Only if you're on floor 1 would you see anything on the wired connection. So if I'm plugged into the port on a switch on floor 1, or attached to an AP on floor 1, I would see that bonjour traffic, right? Or I could advertise bonjour traffic. And then there's the per zone. So this is where it gets really interesting, right? So we can take this down to the actual switch port level. So we can say, okay, that access point is plugged in. I'm going to give the example. This is, again, the locally switched access point, right? So that access point is plugged into that particular switch port. So traffic is being dumped locally into that particular switch port. So I can take that switch port, and then maybe right next to it is a wired switch port with an Apple TV plugged into it, and I can determine only those two can talk. So only if you're coming in on that one AP, and only that can only talk to anything that's plugged into that particular switch port. So now I can get down to the device level on the wired side. I can get down to the AP level on the wireless side, and really define what can talk to what and what services will be advertised, right? So I can go ginormous, right? I can go across the entire campus. I can use the wider mDNS gateway, or the Bonjour gateway on DNA Center, and we'll see what that looks like in just a second. And I can advertise across all my buildings. So I can say, hey, if you're in the student building and you're in the dorm, anytime you're in the dorm, you can still see the Apple TV in the student building, student center. You can do that, right? We can define this. You can cut this up pretty much any way you want to do that. So let's look at a configuration on the switch itself.
Hey, Al.
Yeah, sure.
Before we do this, real quick, we got another question, and it's around location-specific services. Does LSS work if I have an IE switch in the mix? So I'm assuming that's industrial Ethernet.
Yeah. So LSS. What do you think of LSS? LSS is really a term that's based around the wireless LAN controller type of gateway. Yes. So that absolutely would work because you're running local mode, or if you're running Flex Connect in that particular case, then LSS would work. Now, what that doesn't solve though is if you're trying to control a particular wired port on that, right? So on that particular switch. In that case, what you'd want to do is trunk that up. We'd have to know the particular model. I'd have to look at the most current version of the matrix of support for this, but it's supported now even on like 9200 CXs and stuff like that. So depending on which exact switch you're using, we'd have to look at that. If it's not supported on that switch though, you could certainly do it on the next, like a 9300, which that would plug into, or 9500 or whatever going up, 9600, wherever that's going to, right? So you could certainly start to control that as you move up the stack.
Okay, great, thank you.
Yeah, no, great question. Great question. All right, so as we look at the configuration of this, it's relatively simple, right? So first thing we're going to do is we're going to define that this switch is capable at the global level of being an mDNS gateway, right? Or being a Bonjour gateway. And then we can define the service mode. This is, remember, the peer or the agent. We can define this as a service peer or as a service agent. And in some cases, depending on what you're using it for, it may not matter. If you're just using a switch standalone by itself, it really doesn't matter if you configure this as a service peer or a service agent. If you want to use the wide area Bonjour gateway, so you want to use the what's on the controller functionality that's on DNA Center, then you need to define this as an agent, all right? The next thing we're going to do is configure our VLANs to support mDNS. Now, this is kind of interesting because my assumption up until just recently has been you had to actually make this put an SVI on the switch for the gateway to occur. That is not the case, all right, just to be clear. Once you define this mDNS gateway on the switch, so you see this VLAN configuration 115, you have now defined the gateway on that VLAN, even if you don't have a layer 3 interface. So I don't have to take my switch and convert it to some layer 3 switch or something like that. I can just use a flat layer 2 switch, even if that's the only switch I'm trying to do this on, right? All right, and then I'm going to define my services that I want to advertise, and that's things like AirPlay or Apple TV. And so I've defined that list of things that I want to take in and then cache. And then I can also define what I want to let out. And the reason why that's important is I may take in different things from different locations and let out different things from different locations. So I've only defined one set here. There's one in and one out, but you could have multiple ins, multiple outs, and you notice how they're named. Local area bonds are in and local area bonds are out. You can define those based on those groups. Right, so I can have. I don't have to have. It's not a one-stop shop where you have to have. You set up this one set of filters and that's it. You can get really granular with this stuff, right? All right. Now I can also create. So then after you create those service policies or service lists, you need to create a service policy. That's where we take those particular service lists, and then ultimately we're going to apply those service policies to the gateway itself, right? So you can see down here where we apply the policy to the gateway. Now, one of the things I did here, and these are kind of optional, depends on what you're doing. Comes back to that kind of how granular do you want to get. I've defined, in this particular case, you can see there's a location filter. It's called local proxy, and we're matching VLAN 115. Now, typically, I will only set up one switch and one VLAN. You'll see that when we look at the results. Typically, you would set up multiple VLANs here. This is how you can allow VLAN, something you learn on VLAN 115, for example, to be advertised on VLAN 116. And then we'll look in a second here how we can constrict that down to the port level. But this would be, for example, I could say match Apple TV, but because I'm using this local proxy, it's applying to VLAN 114 and 115, right? So you can see now I'm starting to reduce that filter down a little bit more where I can be more granular. And then you can see on the last two lines, and again, you don't have to do this depending on what you're doing from an architecture standpoint. I can actually define groups of interfaces and I can define groups of APs, right? And these can be the same group effectively, right? So I can define groups of APs, I can define groups of, because we're looking primarily at the switcher, I can define groups of interfaces. And then assign those to the multiple VLANs. So I could say VLAN, I could do the same command, group 1 VLAN 116, for example, right, if I had multiple VLANs in there. So I can assign multiple VLANs to multiple floors. I can assign what I want advertised on a per VLAN basis. And I can define which VLANs I want to share across what, right? So tons of flexibility in how we do this. So let's take a look at, if you actually configure this. So this is a switch I configured in the lab. And you can see, so if I do show mDNS summary here, you can see I have the gateway, back up here. Let me do that again. I have the gateway enabled. In this particular case, I have the gateway enabled. Sorry, it wants to, let me cue this up again. There we go. I have the gateway enabled here, and so I have it enabled in an agent format, right? So if we look at the summary here, I can't seem to pause it. Let me just back it up, and we're going to do it this way. We're going to do it the manual way. Let me go down here. So I captured this in the lab the other day. Okay, so we'll go down here. All right, so what you can see here is I have, I've got rate limiting enabled. I've got the agent functionality, right? So you can see up here, I've got this set up as an agent, not as a peer. You can see all of the configurations. It's IPv4, the gateway's enabled. You can see this is on a per VLAN, so in this particular switch, I configured this on VLAN 114, all right? And then if I go down here and I type in show mDNS cache, I can see all the information that was cached. So I just plugged my local a Mac into the switch port of the switch, and all of this information was gleaned for that particular switch port. right? The rest of the config was basically, or the config you saw was basically the config that I shared with you a second ago, okay? And then from a wider bonjour standpoint, this is DNA Center, right? This is an application on DNA Center. And this is what allows us to bridge those gateways or those agents together. So now I can take multiple agents and decide what do I want to advertise between those agents. So how do we do that? So this is the home screen when you first come in. If I actually had multiple switches and I was advertising across multiple agents, you would see information on this particular part of the screen. I don't. I just have one switch, but you can see down here at the bottom, speed that up a little bit. If you can see down here at the bottom, you can see information about what agents, what services, the types of services I'm running. So you can see, again, I had my MacBook plugged in. My MacBook is running Apple TV services. It's running iTunes. It's running the Apple, what is that? Apple Screen. Sorry, getting old, gotta have glasses. All right, so that's it. So that's how you can kind of keep an eye on what's going on here. Also, if you look at the very top up here, you can see I have 3 switches that are added. 2 of them are down right now. 1 of them is up. That's just the switch that I configured the Bonjour gateway on. I just didn't have time to get multiple switches prepared for this. Now, if I go to the configuration, you can see on the configuration standpoint, you can define locations. Now, this locations, if you're familiar with DNA Center, you have sites and floors and buildings. That does not have to align here. Okay, so this is totally independent of what you're doing from a switch location on DNA Center. I can define groups here by whatever location I want. Now, I've picked them into floors, for example. And then within that floor, you can see I have devices that are attached to that particular floor. In this particular case, you can see I have a service filter here set up. I've got 3 instances. So if we look at that particular service filter, you can see in the, man, let's see, sorry. Not sure what I clicked on there to make that go away, but I'm just gonna run it from here. Because it's not cooperating. All right, so if you look at this, what do I have here? I have a switch. I've defined this switch. This is that gateway, right? This is that agent, switch with running an agent. And over here is all the services type that I will allow to broadcast to or from that agent. All right, now if I had another agent, I could define that at another location, then I can define what I want to be able to talk to or from these particular locations, right? So that's how we define kind of who talks to who. This is a certain, so I can define, there's a certain number of service types that are defined as part of DNA Center or as part of this Bonjour application. You can obviously construct your own, just like you could on the wireless LAN controller. So if you don't see what you need here, you can certainly build your own filters for this. And then you can apply those filters to those locations like we talked about. So you can see here what I've got applied to what locations. In this particular case, only one of the switches, again, is fully operational. So from a monitoring standpoint, you can see I just have this one switch that's up and operating. You can see that it's assigned to service filter 1. I have the other 2 assigned to service filter 2. You can see the locations that these are assigned. So this gives us the ability to see where the devices are, if they're up, if they're active. So it's kind of a quick way to monitor this. So I'm going to jump back here again just to kind of wrap up where we've started. So I think this is, if you think about where we started, right, there are 2 different ways to do Bonjour services. One is we can do it with the wireless controller. You may or may not, depending on your architecture, you may or may not have a wireless LAN controller as part of that architecture. If you don't, in your switching, there's still a Bonjour services built into the switching, right? So you can take that it may be a local mode access point, it may be just wired services, and you can construct a fully filtered, fully managed Bonjour network across your entire architecture, right? Across your entire campus, multiple campuses, whatever that is, you can define that across that entire architecture. So it's a great way to apply wired and wireless mDNS across a large campus architecture. Oh, And if you care, if you're using Fabric, it works across Fabric, for example, right? So this is a way to support Fabric and Bonjour services if you're running Fabric. So, all right. That's pretty much the end of this session. So, Dan, is there any questions or anything like that?
There was one more question, which
Okay.
I think you have answered on this slide already, but just to clarify, the question is specifically, do I need SVIs on a 9800 for mDNS these days? But looking at your slide there, go ahead.
Yeah, no, we don't need that anymore. Yep, not required on the 9800 for traditional, and not required on the switches to run the Bonjour services on the switches. So, yeah, it's really amazing. There's a lot of capability here between what you can do on the wireless, and you could use in some cases a hybrid approach, right? You might use in some cases. Now you can't use a hybrid approach on a wireless LAN controller, right? So as a wireless LAN controller, you have to define it as the gateway, or you have to define it as a service peer. You can't do both, but if you have multiple controllers, you could have some operating one way and some operating in the other. So.
All right. I think that's it for questions, it looks like. Any other points here, Al, before we wrap up?
No, I would say if you have any questions on this, if you're looking at a way to implement kind of that combination of wired and wireless mDNS, we've got a lot of flexibility. Reach out to your SEs, reach out to your local TSAs, right, that have expertise in this, and we can certainly kind of walk you through what would be the best architecture for your particular environment, right, from an mDNS standpoint. There's a lot of flexibility here, a lot of things that we can do with this to really help you in terms of mDNS.
Yeah, great point, Al. All right. Thanks so much. Always great to have you on the show. Really appreciate your time. Yeah, thanks.
Yeah, so, the sun is coming up now.
All right. That's good. That's great. All right. So just as we wrap here, thanks again for tuning in this week. We do have some exciting shows coming up here with there were some Wi-Fi 7 announcements here from Cisco this week. And so stay tuned. The best thing is if you can go out and subscribe to our channel, youtube.com/@getunplugged. You'll be notified when we do go live with those new episodes every other week here. And so you can always reach out to us, like Al mentioned, via your Cisco account team. You can reach out to us, email us directly. GetUnplugged@cisco.com, or you can reach out to us via Twitter, X at Unplugged80211, or Threads Unplugged Connectivity. So thanks again, and until next time, stay connected and unplugged.